Hello, this is Mike Lawless, and in this video I will demonstrate a few new features in ADMET Predictor 8. I'll specifically discuss how to generate star plots and interact with distribution and scatter plot. So let's start by reading a file into ADMET Predictor 8.0. So simply go under the File pull-down menu, select Open, and then navigate to the file that I want to read in. And I'm going to read in a what we call a SMILES file. So it's the solubility-100.smi. This program will prompt you for the field for the SMILES string, and this is already in the input file I'm reading, and also the identifier. This identifier should be unique for each row in the spreadsheet. If you do not choose an identifier, then the program will assign a unique number to each compound. So I'll click OK. And the first thing you see that it's read in the file, displayed the SMILES images in this first column over here, and then also read in the textual data, which is the solubility milligrams per milliliter. It's also added a column called AP fragments and previous structures. So with ADMET Predictor 8, if you click on a column once, it sorts it in ascending order. If you click it on twice, it sorts it in descending order. So we can see the non-blank cells in the AP fragment column, and we also see the previous structure column here. So this originally was read in as the chloride salt. This was read in as a sodium salt, and I just kind of edited these and added these two spectator ions just to demonstrate this feature. If we go up to the gearbox, which is the settings, it shows this section here, remove fragments when opening files. We have a ASCII file that has a list of common fragments such as water and then common salts like pyridine, etc. So that's a good way to remove most of the common fragments, and if there's still some left, it will default to removing the smallest fragments. So now I want to clean up this or simplify this spreadsheet a little bit by undisplaying some of the columns. So I can either right-click on a column header and undisplay the column. For example, I can also right-click and delete the attribute. So if I delete the attribute, it will never come back, whereas if I undisplay it, I can display it later. There's another option under the View menu called Arrange Columns, and one of the keyboard shortcuts I use quite a bit is this Arrange Column, and I just use Control-Alt-V to bring up this dialog box. And with this dialog box, on the left is listed all the columns in the spreadsheet. On the right are the columns that are displayed. And so I can just highlight a few of these columns. So I'll do a single click on the user ID, and then I'll hold down my control key to pick these other columns, and I'll just remove those. So now those would be undisplayed. We can also move the attributes up and down, which would be across in the spreadsheet. So I just click OK, and now I only have the structure, the identifier, and the solubility that was read in with the file. Next, I'll compute ADMET properties, and that can be done simply by clicking on the ADMET icon here. You also see the shortcut Control-R. The other way to access this dialog box is go under the pull-down menu and select Data, Calculate ADMET Properties. So I'll click on that. You have the ability to customize the properties. For example, you can turn off the phys-chem or the metabolism or any one of these sets of properties to calculate. We can also click on the properties button. We can uncheck everything and then maybe select a certain descriptor, say log D, to display. So this would only calculate log D, and that's all you'd end up in the spreadsheet. I'm going to check all because I want to calculate all the properties. Again, you could change the pH at which the calculations are performed at. So for example, if you wanted to log D at 2.0, you would just indicate that there. And then I'll just click calculate. So it goes out and it calculates all the molecular descriptors and then uses that in the models to make the predictions. And we also have a box up in the upper left-hand corner that tells you that a new attribute columns were added to the spreadsheet. So the first thing you see are the star plots. These are automatically calculated, and there's an ASCII file in the ADMET Predictor subfolder that specifies which properties to display for each automated star plot. So for the first one are the risk values, so it shows tox risk, absorption risk, CYP risk, mute risk, and tox risk. And the length of these wedges represents the value for that particular molecule. And it also shows the range. So if we go down here for adenosine, the ADMET risk is 4.857. The range in this ranges from 0 to 11.46. If you'll notice in the PCB column, you also have the option of logifying any specific value. So for water solubility, which can have a range here of 7 orders of magnitude in this particular spreadsheet, it's nice to have those arranged for the log value. The star plots can be customized by editing the starplots.txt file in the user's app data local simulations plus ADMET Predictor 8.0 directory. So if we focus a little bit on these column or tabs down at the bottom, the all tabs will show all the data. We can just show the user input. So this is essentially the original spreadsheet we showed before we removed some columns. PChem Bio will display the PChem Bio tab. And also you'll notice that if we, some of the cells are have a gray background. If we double click on one of those cells, it displays another window, in this case the pKa predictions for this particular molecule, and then we can display the fraction ionized versus pH for each one of the microstates, and then show the macrostates, and then several other plots associated with the ionizations of the molecule. Now let's perform a simple query that can be done by going up to the edit button and going down to query by structure property. Another shortcut I use all the time is Control Q to bring up this dialog box. So with this dialog box, you can perform substructure or textual type queries. We're going to do a substructure search, so I'll click on the Medchem Designer button. That will bring up Medchem Designer, and I'm going to simply search for a chlorophenyl group. Click on the chlorine and then bring this back. So now this will display the actual query molecule. If we switch it to text, it will show the SMILES string associated with that particular molecule, or excuse me, the SMART string. We click OK. It highlights 15 of these and also shows the compound or the fragment colored in red. Now, if we just want to see these, we can go up to the View menu again and hide or unhide data. So if we want to see all the compounds that were selected, we can hide the unselected. So that'll just show the ones that have this chlorophenyl group. We can also go back and unhide all of these. Similarly, we can just view the unselected structures by hiding the selected structures. And again, you'll notice these shortcuts. So Control Alt H will hide the selected compounds. Control Shift H will hide the unselected compounds. And again, I use that shortcut very often. Now let's interact a little bit with this chart over here, this distribution chart. In the upper left-hand corner, you can specify what what you're plotting. So it will give a list of all the attributes here, and I want to select S plus log D to plot. Now the default is to display these columns attributes in alphabetical order. I can also click on this button and it arranges it in the order of these tabs. So the PhysChem Bio will come first, and so I can just select log D from here. It makes it a little bit simpler to find common type attributes. So I'll click OK, and now this changes into the log D distribution for this data set. We can show a two color mode by clicking on this button. So the default is to take the selected columns and use this secondary y-axis. So now it's more of a percentage comparison between the selected and unselected rows in the spreadsheet. Again, if we click on the XYZ icon here, we can unselect the use a second axis in two color mode. Now we'll see the number of molecules that have the chlorophenyl relative to all the other compounds in the spreadsheet. Furthermore, we can simply click on a column. It will bring up another dialog box, and it'll contain the 5 molecules that have represented by this particular bar, and we can page through those also. We can also click one of the highlighted ones just to see one of the chlorophenols, and this has one of the highest log Ds in the spreadsheet. Okay, now let's interact with the other chart, and these charts are dockable, so I'm going to bring this out. We can resize this just by pulling on the window. Here I'm going to specify the XYZ or the X and Y attributes here, and in this case I'm going to plot the solubility, the experimental solubility versus our predicted solubility. So on the y-axis I want solubility in milligrams per milliliter, which is already selected, and I'm going to logify this because there's quite a range here. Similarly for the x-axis, I'm going to go down to the the S plus SW, which is our aqueous water solubility model, and then click log again. Now that I click OK, now we've plotted these two values against each other. We can get a regression, or excuse me, a best fit line through here. So the R squared for this is 0.8, and then for the linear regression, the RMSE is 0.163, and the mean absolute error is 0.48. It also shows that there are 100 molecules in here, and this is the relative to the model. So now in this case, if we want to see these chlorophenols selected here, we can click on this, which takes what's selected in the spreadsheet and highlights them in the graph. We can also zoom in on various points in the graph. So if I select this button and then highlight a certain area, it resizes the axes to zoom in on those particular points. Furthermore, I can click on a set of points, highlight them in the graph, and then push them over to the spreadsheet so that they're highlighted in the spreadsheet. So now that I'm finished interacting with the graph, I'm just going to redock it. So I grab the title bar here and just move it over back into the graph area. You can also resize this so you can show more of the spreadsheet or have bigger plots, etc. So that concludes the kind of introduction to autostar plots and some of the graphing capability within ADMET Predictor 8.0. Thank you for watching this video. If you need to contact me, please send me an email at mlawless@simulations-plus.com. If you'd like a little bit more information about Simulations Plus, please click on the link here. And if you'd like to request an evaluation of ADMET Predictor, please click on the link provided down here. I'm Mike Lawless, and I'll see you next time. Thank you.